Thanks, Mike, and good morning, everyone. It's really good to be here this morning, and as Mike said, I hope you've all got a nice warm cup of coffee or tea, and I think we're going to have a really nice time talking about this topic. It's really an exciting topic, and it's one that I enjoy especially because my background is not only in bioenergy but also in building design. I studied architectural engineering at the bachelor's level, and so it's kind of fun to be talking about these two topics that I have some interest and background in. And what's really interesting to note here is that there are a lot of people who design buildings, green buildings as well, and there are some people who work with wood energy, but there are very few people who really do both, who work in both communities, so to speak, and there's some real synergies that we can take advantage of when it comes to green buildings and wood energy. And I think this is a real opportunity that we can look at and see about moving forward to the benefit of all that are involved. Now, today's webinar is going to be in basically 7 bite-sized pieces. We're going to talk about what is a green building. We're going to ask what is wood energy for those of you that aren't familiar, and then ask how can wood energy work in buildings, some of the technical side there. We'll ask why wood energy, what are the reasons behind potentially using wood energy, and where has it worked so far, a few examples. Then ask, well, why not wood energy? Namely, why isn't there more going on in the region? And lastly, talk about making a positive difference. And the focus of today's presentation will be on the Northeast United States with its significant mixed hardwood forests and things like that. And I'll be drawing examples from Pennsylvania primarily with the idea that it's fairly representative of what's going on in the region as a whole. Okay, Charlie says there's a lot of echoing. I'm not sure how much we can do to adjust that. If you could, if you're having problems with sound quality, if you would check your sound settings with your computer, hopefully that'll help out with that. And if you guys are still having a lot of trouble with that, please let us know in the chat box there on the left. Okay, the first question then is, what is a green building? And the term green is really very vague, and for a lot of people it really means very little more than a warm fuzzy feeling when we hear it mentioned. Green, of course, does not necessarily refer to color when we're talking about buildings, except insofar as the color green kind of symbolizes life for many people, and good life, essentially. And so green buildings per se are buildings that are designed and utilized to be more ecologically sustainable. And often actually the term sustainable buildings is used as well, and some people, and myself included, think that's a little bit more of a more descriptive term, and I'll probably interchange those terms during this webinar. It's kind of funny when you think that the term sustainable is actually the more descriptive term, because anyone that works with sustainability knows how difficult it is often to be able to define what really constitutes sustainability in almost any system. But that being said, what does this really mean for a green building or a sustainable building? In general, it tends to break down to 4 main themes. The first theme being the building site. Can we design the building to enhance the local ecosystem and encourage the use of public transportation? And that's kind of a funny one to jump in there, but the idea there is that excessive transportation requirements and excessive use of vehicles is in general a detriment to the ecosystem and the community in general, and I think that's probably a reasonable statement to make, although I find it very frustrating when there's not ample parking at a building, but that's maybe my own issue. So moving on, the second area, building materials. Can we select renewable, recyclable, non-toxic materials for the building so that over the lifetime of the building there are less issues there? Okay. Thirdly, building systems. Can we design to minimize energy waste and maximize the use of renewable energy without reducing the quality of the building services that are provided? And then lastly, occupant health. Can we design to provide healthy conditions inside that building? And when you look at that, really, that's mostly just common sense for good building design. But unfortunately, it's common sense that has been used all too infrequently in the building industry in the generations gone by. And so green buildings often is simply a replacement term for good building design, right? Now, something as complex as sustainability for a building, it's difficult to distill into a single numerical scoring system, but people being what they are, that certainly hasn't stopped us from trying to figure out how to come up with a single metric or way to measure what means or how green or how sustainable a building is. And by far the most successful rating system in the United States, and in fact it really is the de facto standard, is the LEED rating system. And LEED stands for Leadership in Energy and Environmental Design. And that's kind of an interesting name because the implied assumption here is that energy and environment is what sustainable buildings are all about. And of much lesser importance are the issues of economics and society and the sustainability of those sides of sustainability. But that's a little bit of an aside, but it's certainly worth thinking about in terms of how buildings should be designed and built in our country. Now, the LEED rating system was developed by a group called the United States Green Building Council, and they've developed this certification system, which is a very thorough process of taking a look at the design and construction of a building and allocating a certain number of points, or sustainability or green points, to that building. And if the building gets a minimum of 40 points, it is certified to be a LEED building. 50 points, it's given a silver, 60 a gold, and the highest rating would be a platinum rating, which is 80 points or more on this scoring system. Now, again, it's interesting that they used silver, gold, and platinum. Why not different shades of green, for example? But I suppose precious metals still hold a much stronger a grip on our collective psyche than the colors of different leaves and grasses and things. But at any rate, if we look a little with a little more detail at this scoring system, it's certainly a little more complex than this, but there are several categories, and there's a total of 110 points that can be allocated to a building, and it's broken down into these categories of site development, water efficiency, energy in the atmosphere, that's the largest category in terms of how many points is allocated, materials and resources, indoor environment, design innovation, how innovative the design is, and then lastly, regional priority, which is kind of an interesting one because it allows local groups to identify specific sustainability topics that are extra important and basically assign bonus points if those areas are addressed. So for example, in the desert Southwest, water conservation and water efficiency are probably some of the most important issues. So a building in that region would probably be given bonus points if it is especially water efficient, above and beyond the 10 points that are designated for normal scoring. So when I take a look at the details of this scoring rubric and pull in what are those 26 points for site development and how are they allocated, yada, 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 I see several spots that could be addressed by wood energy systems in a building. And the way I see it is that you could get basically a maximum possible impact of wood energy of as much as about 21 points within this system. That's enough points to turn a certified project, minimum certified project, into a gold rated project. And so that's an interesting little thing to think about in terms of wood energy and these green buildings. But I'm getting ahead of myself a little bit. So excuse me. All right. So anyway, here are a few examples of LEED-rated buildings at Penn State University. In the upper left, we have the School of Forest Resources building, and that's that building features things such as a vegetated roof and use of daylighting and energy efficiency. And excuse me again. In the upper right, there's the Stuckerman family building. The Stuckerman family does not live there. They provided funds towards the construction of it, and it houses the School of Architecture, and there's incorporates daylighting, very low water use, and the purchase of wind power to power that building. The bottom picture there is the Dickinson School of Law, which again incorporates a lot of these same systems and themes into its construction. And it's kind of interesting to note that two of these buildings are actually colored green as a way of trying to visually reinforce some of the priorities that went behind the building and the design and construction of this building. Now, how much does this all cost? People have analyzed the cost of this LEED rating system, and it really varies widely. It can be as high as even 40 or 45%, now a 45% increase over normal construction costs, but typically it's somewhere in the 5 to 10% range in terms of increased cost. And of course, the operating cost of these buildings tends to be lower over time, so you have an opportunity to recoup that. Now, the other thing to note that these are typically not low-cost structures. They are usually high-profile, high-end facilities. However, many organizations and groups are now requiring LEED certification for all of their new buildings, and that's true of Penn State University as well. All new buildings at the university are expected to be LEED rated. Okay, so that in a nutshell is green buildings in America. Now, jumping on to the next question, what then is wood energy? All right, and wood energy is a pretty broad topic, so today we're really going to limit it to wood energy for buildings. And so stated simply, wood energy is all about using wood products, that's forest or field products, as an energy source for a building. And in the slide here you see a photo of some mixed hardwood forests typical of the Northeast, and then some rows of short rotation woody crops in the lower photo. Another opportunity for producing and growing wood as an energy source. Now, practically speaking, the most common fuel type it would be commercial grade wood chips. They are economical, they are widely available, and they are in use today. However, there are other forms of wood fuel that may be possible, most notably wood pellets, and we're seeing some growth in commercial use of wood pellets, and larger densified products such as briquettes or cubes, depending on how they are manufactured. The most common form of utilization of this fuel is direct combustion to produce heat. And there are some other variations of that, but in terms of practically how it would be, how wood energy would be used in a building, this is pretty much the standard. Okay. Now, sometimes people like to use the word bioenergy instead of wood energy. The main difference being that bioenergy could potentially incorporate non-woody fuels, such as, for example, field crop residues or perennial grasses and things like that. But in the Northeast United States, wood certainly is the most common and affordable option for bioenergy, and it will probably continue to be the dominant fuel source for many years to come. How can this work practically in a building? All right, there are several ways that wood energy can be incorporated into a building, and the most common approach for commercial buildings is to use wood combustion to generate hot water for space heat. Right? Fuel storage is an important component to the system, and it's one that many building designers are not really familiar with. But the manufacturers of combustors, the combustion systems, typically bundle fuel handling in with their equipment, and that helps simplify the process of incorporating that into a building. Now, I did not put all the details on this little sketch here. For example, you don't see the emission control equipment, which is used to ensure clean air in and around the building. And I also did not depict thermal storage, which is not always used for wood energy systems, but it can be a very effective component for improving its performance. The second common configuration for wood energy in buildings is to utilize wood combustion to generate steam. That steam provides both heat and power simultaneously to a building. Basically, the steam that is generated is fed to a steam turbine. It spins the turbine turns, generates electricity, and the steam that comes off of that turbine at a lower pressure then is provided to the building or is turned into hot water depending on the building's needs. Okay, this is not quite as common as a heat-only system, and typically it's only really practical for larger buildings or collections of multiple buildings, and the cutoff point is a little hard to determine. It depends on a lot of factors, but it's somewhere around the 500,000 square foot range. So that's a really, really big building or series of buildings that you need if you're going to consider providing heat and power through a steam turbine. A third scenario that I wanted to bring up, not because it's really used, it's pretty much untested in the United States, but there has been some successful implementation in Europe, and maybe it has some potential for the future, is the use of an organic ranking system to generate heat and power. And it's just a little bit of a variation on the steam-based combined heat and power system. But because the organic ranking generator is not utilizing steam directly, it avoids some of the maintenance costs associated with steam-based systems. And so because of that, it might be suitable for some smaller facilities than are usually candidates for combined heat and power. But the cost effectiveness of all this is kind of uncertain at this point. Okay, but it is an intriguing possibility that might make sense in the years to come. So we've seen how wood energy can work, how it can be slotted into a building. Now, the next question then is why? And there are several good reasons or several good answers to that question. Right? The first is that you have the potential to significantly reduce or even eliminate your building's dependence on fossil fuels. And for a green building, a sustainable building, that's a big deal. Take a look here at these pie charts that show energy use for two different buildings. They are both LEED rated green buildings. The one on the left does not use wood, and the one on the right does use wood. And the one on the right, the folks really kind of went hog wild with a bunch of different local energy generating technologies. But take a look at what's providing the majority of that building's energy on the right, or the largest portion, and that's wood. It's wood energy providing 41% of the energy needs. Compare that to the building on the left, where all of the energy, more than half of the energy is coming from natural gas, a fossil fuel, and then over 45% is coming from electricity, which, depending on where they're buying it, may or may not be from a renewable source. So wood energy has real value there in terms of reducing fossil fuel dependence for these buildings. The second reason, right, you have the opportunity to match the supply of energy to the demand for energy in the building, and not the other way around. This is a real problem with most renewable energy sources, that they produce energy unpredictably at times when it is not needed. Now take a look at the two lines on this graph. The red line, and these are actual measurements, the red line shows measurement of a photovoltaic array, the amount of power that's was produced on February 22nd, that was Tuesday, right, over the course of a day. From from midnight, rising up through the middle of the day. Some clouds showed up in the afternoon. The red line drops down in the hours of the afternoon, then back down to 0 in the evening. Superimposed on that graph is the relative power use for a building that we measured on that same day. And you see that those two graphs don't nearly have the same shape, so that it's impossible to directly utilize, for example, photovoltaic power at night when the sun is not shining. And of course, that's kind of obvious, but it points out the issue that's a real challenge with a lot of renewables, except for wood energy, because wood energy systems can be ramped up and ramped down to meet the demand and meet the needs of the building, which is a very nice thing. Okay, third reason. You have the opportunity to integrate your building's energy needs with the ecosystem. This is something that the LEED rating system really doesn't take into consideration, but it is an important and a very valuable component of a truly sustainable building design. So what do I mean by saying this? Well, take a look at this lovely landscape. Let's suppose we decide to build a building here, a nice sustainable building that uses wood energy. What are the potential things that can be happening there? We have the potential to produce the fuel on site in a manner that not only provides local renewable fuel, but also enhances the local ecosystem by way of providing habitat for flora and fauna, plus water quality benefits as well, if it's all managed properly. Now, this is truly a facility whose energy use is integrated with the local ecosystem, and that's something that probably bioenergy and wood energy is unique in terms of what it can bring to the table for sustainable buildings. The fourth reason I want to bring up, and it's the final reason I'll mention today, is that wood energy is proven, it's reliable, and it's cost effective. Once again, these are nice things to bring to the table when we're talking about design options for a building. All right. For example, the Mountain View School District in Kingsley, Pennsylvania has been operating since 1989, providing wood heat to the elementary school and high school. Excuse me. It's been operating well and reliably, and the people there are very happy about it. And those of you living in different parts of the different regions of the country in different parts of the Northeast probably have similar locations where similar stories can be told. Analysis of a lot of these wood energy systems has come up with the result that the simple payback, at least for retrofits, so installing in an existing building, has typically been in the 7 to 10 year range. And that's without counting grants or incentives. Now, for new construction, the cost effectiveness should be even better, quite frankly, because you're not pulling out old equipment. You're not having to adjust the building for something it wasn't originally intended to hold. So what are some examples of wood energy in buildings? Okay, here's an institutional example. The Elk Regional Health Center in St. Mary's, Pennsylvania. They installed wood heat in 2007. It provides low pressure steam to the hospital and an adjacent assisted living community facility there in St. Mary's. And it's been operating very well, very economical. Residential example, the Bruderhof community in southwest Pennsylvania. This is a residential community where people sort of live together and work together, kind of a communal living setup. They installed a wood heating system in 2008, and all of their buildings are heated by hot water that's provided from a wood-fired biomass system that's there on site. Again, working well. It's a nice design solution. Third example, an industrial example, Evergreen Community Power in Reading, Pennsylvania, in a fairly developed urban/suburban location. It's a very large facility that supports an adjacent corrugated paper plant by providing by generating 30 megawatts of electricity and providing steam for the manufacturing plant, and allowing that manufacturing plant to be economically better off and also be able to market their products as being produced using sustainable renewable energy. They have 27 employees there that are taking care of that plant all in and of itself, and they utilize wood and construction debris as their main fuel at this point in time. Now, if we take a look at how many facilities have been built and when they have been built in Pennsylvania, what we find is that we're looking at what appears to be a real increase. It seems like wood energy projects are on the upswing. Okay. However, keep in mind that this number is still quite small in the grand scheme of things. And to a degree, this number is probably dependent on government grants that are used to cover part of the installation cost of these facilities. And what's interesting to note is that, at least in Pennsylvania, none of these projects are LEED-rated green buildings. And so you have to wonder if maybe the interest in green buildings could be a very nice motivation, continued or increased motivation for wood energy, possibly replacing or augmenting the financial motivations that have been predominant up to this point. Now, if none of these wood energy projects in Pennsylvania are LEED rated, what about asking the question, well, how many LEED rated projects utilize wood energy? And so I took a look at the Green Building Council's database of facilities in the Northeast, those that have case studies or information about the systems that are in use. And within the Northeast, basically Maine down as far as Maryland and West Virginia, I took a look at that, and 9%, by number, 9% of all featured projects use biomass energy of some sort, which seems, maybe that seems like a good number to you, maybe it doesn't, but when you actually take a look at the square footage of the buildings, it's only about 1.4%. So it's actually just a few small facilities that are utilizing wood energy, and it's my assessment from looking at that wood energy is really underutilized in the region when it comes to green buildings today. And that really makes you wonder, well, if that's the case, well, why? If it's underutilized, what's going on? Now, a study was recently commissioned by the United States Forest Service to ask that exact question by surveying and talking to building designers and asking them about wood energy and why they do or don't utilize that. And what's interesting that came out of that study is that probably the biggest answer is that the design community simply is not aware of wood energy. Typical quotes from that study were things like, "Why have we not heard this before? This technology can help us." And to be fair, there are some first of all, there are some things that wood energy equipment manufacturers can do better to make their equipment more easily utilized by the building design community. And there are some situations in some buildings where wood energy does not make sense. But the real take-home message here is that there is a grand opportunity to not only help the green building community, but also develop the wood energy industry as well. And so with that in mind, I'd like to move on to my final point here, basically, which is that I'd like to challenge you to think about making a difference here. Here's a need, here's an opportunity. All right, it's a little bit of a challenge that maybe we should be thinking about how we can plug into this need and kind of bridge the gap between these two communities, the wood energy community and the green building community. All right. There, by my count, there are 76 local chapters of the Green Building Council. And there's a real opportunity there to reach people who are really excited about sustainable buildings and give them an opportunity to think about how wood energy may fit and may meet their needs. Okay? And the whole idea is that a lot of wood energy projects historically have happened because there was a local champion, someone locally who was excited about the topic and talked it up and got others enthusiastic about it. And there's a really good chance that there are several projects in your area that would really benefit from wood energy, not just from a sales job, but actually that it would make sense and it would be a valuable component for that project. And I think that your enthusiasm and informed opinion can and will make a difference, so that wood energy is used in those many situations where it makes sense as a renewable, reliable, and sustainable energy source. Thanks very much.
Thanks, Dan. I already see some question in the chat box. So you want to, I guess, you can just read them and then answer it, right?
Okay, Jordan, you're asking, how was I able to gather information about wood energy projects in Pennsylvania? Are these numbers available for the United States, and how might they compare? The information in Pennsylvania I gathered informally, simply by talking with, meeting with, visiting different facilities and gathering that information manually. So there is not a centralized database of that. Chuck Ray here at Penn State has some information on the Northeast region that he put together, but other than that, I'm not really aware of a nice comprehensive catalog of wood energy projects and their characteristics. Yeah, that's a good question, though.
Yeah, please type in your questions if you have, or comments. While people are doing that, I'll throw out a question for Dan. I know the payback period is nice for people to see, 7 to 10 years, as you mentioned, but is that, because it doesn't account for the time value of money, is that really a good representation of the trade-off between the different energy sources in converting to bioenergy? Or should they be doing a more detailed life cycle analysis? I must have stumped you on that question there. I see some other people typing in anyway. We have a question.
Mike, I had my microphone on.
Okay, go ahead.
Okay,
go ahead and answer.
Okay, thanks, Mike. I'm sorry, I did have a brilliant answer that I just went through with the microphone off, so I'll try to try to repeat it. No, that's a really good question. Economic analysis and more detailed economic analysis that takes into consideration other factors is important, but I really like to utilize simple payback for a presentation like this because it's more it's easier to understand, and it really, I mean, quite frankly, at this course of an analysis, you know, the difference in value between a payback analysis and a rate of return probably isn't that important. But of course, when you start to look at an individual project and whether it should go forward or not, then some of the more detailed financial and economic analyses make a lot more sense, I think. And so I guess what I'm trying to say is I don't disagree with you, but I still like payback as a nice way of giving a sense of how economical a project is in general.
Okay, thanks.
Okay, sure. Okay, we have a question from Lance. I don't know if everyone sees this on their screen, but he says, with the reduction in price of natural gas, how can this fact affect the use of wood energy except by those that are committed to green building? Okay, that's a good point. So people that are looking only at the bottom line right now and today are looking at gas. Natural gas tends to be less expensive to install and very easy to utilize. Maintenance costs are lower for natural gas systems. And so the pure economic driver might be a little lower right now, but as many people point out, the cost of natural gas tends to fluctuate wildly. And so I think all we have to do is hold our breath a little bit and see what happens to the price of natural gas. Now, this is just a guess, and the Marcellus gas deposits in the Northeast are pretty significant, so there may be long-term low costs, but that's a real issue that you bring up. And so, however, for green building, which you also point out in your question, it's not merely about costs, and that's where something like wood energy comes in very nicely, because we can be at least cost competitive with some of the fossil fuels, and we can provide additional sustainability attributes that make wood energy even more attractive to those people. Okay, Lewis, you say, appreciate the whole systems approach, rarely utilized. Oh, well, thank you. Those nice comments, Lewis. And it is important, and I think that's one of the real benefits of getting involved with the green building movement, is because they're concerned about the big picture and what their designs are really doing in the larger scope of things. And I think that if that's something that you guys are interested in, I think that contacting some of the local chapters of that group could be a really valuable thing to do in the years to come.
Do we have any other questions? There's also a comment about access for the slides. Yes, we're recording this webinar, and the slides will be available at the website where all the other webinar information is provided. So we have a question from George there, Dan.
Okay, before I answer George's question, I'll just add on to what Mike was saying, and that in terms of the slides, I'm very happy to send you a copy of the slides by PowerPoint if you'd like to adapt them to your region and area and utilize them. Just send me an email. My email address is DEC, as in December, 109 at psu.edu. And I'll also just put on the last slide here, which just shows a few resources in the region, internet resources for getting more information and pulling out more useful stuff about wood energy and green buildings. Now, George is asking, are there concerns about state and federal air quality regulations that may limit planners enough to keep them from considering wood energy projects? That's a very, very good question. The EPA just this week has released its MACT standards for emissions, and they are very stringent emissions standards. Now, two things I think we need to bring up in reference to that, and the first is that these regulations that the EPA has just released, it's going to be a long time, probably going to be a long time before they actually become enforced, because there are a lot of legal challenges to that, and there's a lot of question as to whether they're really practical or sensible. So it's probably going to be several years before that happens. And then the other thing to keep in mind is that emissions from wood energy systems are really a function of the emissions control equipment, and the cost of meeting some of these standards, even as they are now being listed and and put out there is actually probably not as high as some people think. I've talked to some manufacturers of combustion equipment, and they think that while it will add a bit to the cost if they have to meet all of these new regulations, it will not sink them, so to speak. It's not such a high cost that it would make wood energy impossible to implement. So that's not an official, analysis, but that's just sort of talk around the table. That people's feeling is that it's something that is a little bit of a concern. It could increase the cost of wood energy to a certain degree, but it's not something that's going to kill the industry.
Last call for questions. I know it takes a couple of minutes to write them and get them up there, so we'll give a few more seconds. But in the meantime, I want to thank Dan for this very informative talk. Again, the intention is to educate not only professionals, but the public and people out there about wood energy. That's the point of the series. And we're just trying to provide a scope for more extension activities in wood energy, as I mentioned at the beginning. We don't have a formal evaluation, but we appreciate your feedback. You've got our emails at the website. Just let us know what you thought about it specifically. You can write that in the chat box as well. I see people doing that. Or you can just email us, and especially extension ideas. Some of you might remember that we did send a survey out originally to get ideas about webinar series talks and fact sheets and so on, and we're working on those. But as times change, you might have new ideas that you want to shoot us. We're always looking for good speakers. We're going to be continuing to do this on a monthly basis. So again, thanks for coming in, and it looks like we still have a little bit of time, so why don't we take Jordan's question here. Crystal ball question. Since I'm just a moderator, I'm going to turn it back to Dan to see if he has a comment on it. And put your microphone on.
Thanks, Mike. Okay, what do I see as being the biggest innovation in wood energy in the next, say, 10 years? That's a tough question. I think that, and I'm looking from an engineer's perspective at the technical side of things, I think that a different form of the fuel could potentially be a real innovation in the next 10 years. And what I mean by that is that, for example, wood pellets are really, really handy and easy to move, to store, to handle. Wood chips are cheap relative to wood pellets, but they're not easy to move, handle, and store. If we are able to develop, and some people talk about these mini chips or smaller sized wood chips, if we can come up with a product that has the cost benefits of a commercial wood chip but has better handling characteristics like a wood pellet, I think that would be a real head turner that would allow for example, simpler automated delivery, storage, and handling that would not only lower the cost of equipment installation, but would bring about some interesting business opportunities for people who are delivering and servicing these systems. That they can just, instead of, for example, right now wood chips are typically delivered by a walking floor trailer. If you could blow that in pneumatically in a cost-effective manner, which a smaller size material, you would be able to do that. That might really be a nice thing. So off the top of my head, that's the first thing I would think of. But there's probably we could probably come up with a neat laundry list of maybe 10 10 things on our wish list that we'd like to see in the next decade, and that might be a fun exercise to go through. Chuck Ray is asking about cellulosic ethanol and wood gasification. So I'm guessing, Chuck, you're saying that you think maybe that's going to be a big innovation, and maybe so.
Yeah, I'd have to second Chuck on the cellulosic ethanol. We already seeing a lot of innovation and upstart venture capital type companies who are approaching us in Pennsylvania and probably in other states to to source feedstock to test some of these activities. So I see others are throwing out comments there about their ideas of innovations. Lewis mentions microground wood technology. Absolutely. Um, you know, I think there's going to be a lot of opportunity. The question I would have for the cellulosic ethanol is the economics of it. Is it the best use of wood compared to some of the thermal applications that Dan talked about in this talk? Well, I think we're getting towards the end of the hour here. We still have 10 minutes, but since there are no more questions, I'm going to call this webinar to an end, and I appreciate all your comments. And if you have any further comments, please let us know. And we look forward to seeing you on March 25th, 11 a.m. for a talk by Brian Kittler on linkages between woody biomass and carbon accounting. A very important topic that we should be all aware of. So with that, thanks. Have a great rest of the day and weekend, and we'll see you next month. Bye.